Hello and welcome to the corridor level builder tool. And in this part we will gonna start out with the basics of the tool. So here in Houdini, let's build the tool, and the tool will be controlled by a curve, so I would like to have a curve. Before I can create a curve, let's also create a geometry network. So we can actually create this geometry. So in here, using a curve node, and now I can draw a curve in my viewport. For the moment, I want my curve to be nicely on the grid, so I'm going to enable my grid over here, and I'm going to also click this handle to then actually create the curve. And one more thing is then the snapping, so the first snapper over here is grid snapping. And one thing important is that we zoom out until we have a decent range, and now we can draw our curve. If you would be staying in a very small range and you load in the tool in Unity, you would have a very small level builder tool. So we're going to zoom out maybe like 50-50, so it's like enough space, and let's just draw a random line like this, for example, and press enter when you're done. So we have a line. We can still edit the points. You can hold shift to continue building the line. So if I hold shift and click, I can continue building. So this is the shape my corridor should follow. So what I first want to do here is place down a transform. And this transform will be sort of a failsafe in case, for example, a point is not perfectly on the grid. Like maybe a point is going like this or going like this. So they're not nicely placed on the grid. So for this tutorial videos, we are only going to support for one floor, and I'm going to scale down here this to 0. So in here, I'm going to fill in 0. So whatever I'm doing over here, it doesn't affect too much the result. Then I will be resampling this. So with a resample, we're going to create multiple points on the line, and as you can see, there is not much happening. But if I enable over here the points, we can see that a lot of points have been added. So then I'm going to use a fuse node. And with this fuse node, we're going to control the line more. So we're going to go over here in the snapping modes, and I want to change this to a grid shape. So we're going to snap the line along to a certain grid. And I can choose the spacing over here, and I will copy this reference here by just dragging it and referencing it. So whatever value I change here, it will also be changed in the other values. So referencing that over here. So I want to have a spacing of 8. This can be an important value later on. So the grid is now snapped on 8. So every time there is a point, it can be divided by 8. So that's now a more controlled way of the curve. If I were to compare the curve, we can still see it's staying similar to what we have, but just a bit more in a grid shape. Now I'm going to disable my grid again, and I will also be placing down here a null node. And I'm going to name this null node output snapped line. So later I can always call this line if I would need to have it. Then on this line and these points, I'm going to copy a grid. So grid, and of course the copy to points. I'm going to copy the grid on these points. So because I snapped here on the value 8, my grid also needs to be size 8, 8. And as you can see now, they are nicely connecting with each other. So I have sort of my first look of the layout of my corridor. So we can see that we can walk here, and then here we have a little bit bigger space, and then we can walk over here. So if I change the curve, I can easily make variations or do something like this. Make a bigger space over here. Can, for example, connect this over here like this. In this stage, I'm also making sure that my line now has some variations in here. So I can later on see earlier, when I have an issue, I can see it early. So after this, I also want to make sure that my rows and columns are 9 and 9. So if I would, and the reason why I fill over here these columns and rows 9 is just because they're nicely aligned to the grid. So just stay to the grid. So that's nice to have. And after that, I want to fuse them. And the reason for this fuse, if we look over here, these pieces are not fully attached to each other. But if I fuse them, these are now fully attached to each other. Then I want to add a normal. And in this case, I'm going to do a point normal, and let's view the normals over here. So this is going to be quite important, is to see our normals. And we can see that they are nicely facing up. If you want to increase this size, you're going to press D in the viewport, and we can go over guide, and we can over here increase the scale normal. Like we maybe can scale it a little bit more, so it's clear what we are doing. After that, I'm also going to create a no node again. So no. And I'm going to call this out the ground shape or the floor shape with divisions, because this is a shape with a lot of divisions. And now I want to get rid of all these divisions, and I will be using a flatten edge here. This will flatten edges. So this is a tool from the labs. So make sure you have labs installed. If you don't have them installed, you can always find them over here and update them. So now we have a clean shape. So as you could see, by this node, it just cleans up the shape, and the most important points are now displayed. And again, creating a null node, so I can call this information later on. And I'm going to call this out ground plane. And in here, I'm going to create an object merge node. So we can reference this object. So here, object, and every time I would render the object merge node, we get this result. So this is the first setup, and let's create a frame around this. So we can press frame just to keep some structure in the network. And this is then where my setup starts. So everything that I will doing next will start from this information. So that's why I'm also keeping the merge node here, because what I will be doing next is I will just copy this node and I will start my network over here. So next, what I want to do is I want to create a system for the walls. So I'm going to use an extrude. And in this extrude, let's increase this, and I'm going to fill in 8 to be consistent with everything. And I will also disable the outputting front, so we only have this shape. Then I will be resampling this, so resample, and let's fill in here to the length value 4. So we have this shape then. Then I'm going to use a normal, set this to point as well. So we can see that they are having a very specific direction. So I'm going to fuse them as well in case we have overlapping points. Then I'm going to delete the corners, and I can use a group for this, group node. And in this group node, I'm going to set this the name corner. And I'm also going to set this to edges, and I'm going to enable the edges mode. And here also enabling the minimum edge angle. And by enabling this, we can already see that we sort of have selected the corners, because I don't want my walls to be placed on corners. So I will be making a difference between if it's a corner or a wall piece. So I will be blasting this, so blast. And over here, corner pieces, and now we have deleted all the corner parts, which was the result I was looking for. Then I want to select the bottom line, and I can do this also with a group. So group. And there are multiple ways we could do this. But what we can also do is setting this to points. And we can use, for example, the bounding feature, like bounding objects. And I can use a polywire on my original shape. So over here, if I use a polywire on this shape, we will now be selecting all the points at the bottom. So all the points at the bottom are now being selected. And then we can again use a blast node and blast these away. So in here, group 2 in my case. And now I have the bottom line. Then I can also place a transform node. And with this transform node, the only reason why I'm placing it here is I can then easily move or lower my walls, just in case I need to tweak it. Then next I'm gonna loop over each connected piece. So what that means is if it's connected, so in here some pieces are connected by a line, this will only be one loop. So each connected piece. So in total I have here 15 loops, and we can also, for example, go through single passing, and I can see what each loop contains as information. So as you can see, we can go over them one by one. Let's take this as an example. What we can do here is use an add node, and we can delete all the geometry except for the points. And I'm going to use another add node. And in this other add node, I'm going to go here to the polygon menu, go to the groups, and by just clicking on this, it already restored this connection. But instead of restoring this, I want to go in here to this menu and go here to group of n numbers. And you can see it's automatically creating this. So it's connected point 0 and 1, 2 and 3, and then 4 has nothing to connect with further. So 4 or 5 doesn't exist. So what this is doing is I have now a small system that can make a big wall and a small wall. So whenever there is a connection, this means that there will be a bigger wall. And whenever there is just a point, I will just use my small wall in Unity. So when I loop over all the walls, we can then have either bigger walls or smaller walls to just make sure we don't have any holes in the wall. So this is just a small system for that. Now we need to make a difference between when there is a connection or when not. And the way I'm gonna do this is I'm just gonna use a clean node, and by just placing down the clean node, it just deleted those smaller points. As you could see over here, I have all of these small points, and now it just deleted them in the clean node. So the result of this clean node is already my result for my larger pieces. Then I'm going to use a for each primitive to loop over these pieces. So for each primitive, because each line is a primitive, as we can enable the primitives, we can see they're all primitives. So we have 28 of them. And I will be fusing them into each other. And if we increase the fuse a lot, we see that all the points are deleted, but we have to enable or disable here the remove repeated vertices. And also my normals are gone, so don't recalculate the normals. So what we have done now is we created from our line sort of the middle point. As you can see here, we just calculated the middle point of these lines by just looping and fusing them. And let's make a group from this. And this is then what I would say is my bigger wall or large wall. So just call it large wall, and everything is selected in here. And make sure you set it to points, so everything is selected over here. Then I need to calculate the points for my small wall. And the way I'm going to do this is I'm going to place down a box, and I'm going to copy 2 points, all the boxes on the points of the bigger wall. Like you can see over here, if I increase this a bit more. So everything that is not overlapping with a box will mean it's a small wall. So what I can do is again use a group node, and I can use this as a bounding object, and I will be also starting from here. I'm going to make sure this is set to points, and also making that this is a bounding region. Now everything that is selected is for the bigger walls, so we can just blast them away. And now we have the points for the smaller walls. So these are the bigger walls, and these are then the smaller walls. And I will also be creating a group here for this. This will come in later handy when I want to create a more complex wall system. Now to demonstrate this more, I'm going to use the copy 2 points to demonstrate this. So in here I just took a box and I copied 2 points and placed them on the correct points. So you can clearly see now that we have larger parts and smaller parts. And also here there's some spacing between the corners, so we can have a custom models there. So the system is also done for now, but I will be returning to it later to make it more complex. And let's already give it a frame. And this is then my first wall system. You can already test this if you want to. You can go here to the curve. You can grab a certain point and we can play around with it. And you can see that it changes the layout. Next, I want to take care then of the corner points. And from the corner points, I want to start from the divisions actually. Because I first want to think about how will I be able to get the information from corner points and convexity. So I will be having a object merge node, and I will building a small system here next to it. And I can drag and drop this null node over here. So now change to divisions, and I can build a small system over here. So first I'm gonna again extrude this shape like this, and let's make some changes in it. Let's again put this to 8. I don't need the front, and also let's give it some divisions, like also maybe 8, so they are nicely squares. So now I have my base shape, and I want to calculate which parts are convex and concave. And by default, if you have the labs installed, there is a measure node, measure curvature. So we can measure it where certain parts are. So by just plugging this in, it already kind of gave what I wanted. So you can see that certain parts are green and certain parts are red. So this is what I wanted. Now you can also see that it's not perfectly coloring it, like sometimes it goes a bit here, and we can make this better by going here to the method and changing this to measure. And we can see that it's now giving us a cleaner result. So based on the input shape you have, you might have to change the method. Because in my case, I have a flat shape that is open, and the measure works way better on this one. We can already here also boost values, like we can increase the intensity, but we're gonna make sure that we're staying this in a 0 to 1 range. So with this result, I want to filter out certain values. So first of all, I want to get back to my align shape. And the way I'm gonna do this, I go back to my extrude, and I'm gonna enable the back boundary groups. And I will be blasting this. So over here, blast node, and fill this in. Now, by filling this in, nothing really happens. But when you here click delete non-selected, now we have a result that is only made out of points. And we can see that certain points are being colored red and certain are being colored green. So I can do another blast node, And in this other blast node, I can now write a little expression. I can say, for example, look at the color green. And if it's, for example, bigger than 0.9, then this is being selected in the group. And of course, this needs to be set to points because we want to look in the color of the points. And you can see that all the red values are now being gone. And if I want to have the reverse, I can just click here, delete non-selected, then I have the reverse. So in here I'm filtering on the red. We can also then, for example, filter on the green. So you can get both of these values if you want that. And I want to create a null node here again. And this is then the output of the system. And I'm going to call it out my corner points. Because based on these points, I can now make certain selections. Then over here, I want to export another null node for later on. And this will be used for normals. So I'm going to go over here, click the normals, and I'm going to set this to point normals. So you can see the points are facing outwards. And create a null node for this. I'm going to call this out normal direction. So this is something I will be using later on to fix certain normal values. And this system is also done, and I'm going to keep this, like I said, on the side here, as this is my system to calculate my corners. Then I want to make the positions of the corners, and I'm going to start again from this base shape. So I have the base shape, and I'm going to extrude again. So extrude, deleting the front. And I also want to enable the extrude front seam, so the green one, and I'm going to blast it away. So here, and now we have the shape. So you might be wondering why I did this. So I did this a couple of times where I used the extrude and then the blast node. If I look to the original shape, we can see that there is here a connection. So this connection is being created in the flat, this all flattened edges, and this can conflict in my system. So if I would, for example, resample the line, it will also being resampled over here, but I don't want that. So what I did here is I extruded it, and now I got rid of the line. So the shape is then sort of like fixed. So I deleted this line over here. What I can also notice here after I did the extrude is that the normals of the points are already at a very specific position. So if I go over here, we can see that my normal is at an angle of 45 degrees. So I know this, I can trust this amount. So this is already in a good direction for me. So I know that each normal has a 45 degrees angle. So they're not randomly, so they are kind of controlled in where they're going. So now I want to have a group. And in this group, I'm going to select all 10 the concave edges. So I will be getting the information I made over here. So I will be getting an object merge node. And I will reference this in over here. And I will use the bounding features again. So I'm going to place down a box and a copy to points. So plug this in over here. And now I have this box on all the concave points. So in this group, this will be my convex points. Convex points. This will be a point group, of course, and we're going to use then the bounding regions to select these points. And what I can do now is I can use the split nodes to then split these points. So in here, fill in the convex points. And now we have made a difference between convex and concave points. And again, we can test this then further by using a model and copying this on the points. So in here, I quickly made a band model. So I just took a box. put a bend modifier on it, and then scale it to the right position. Also one more thing, make sure that the split node is also set in here to points, because we need to look at the point groups. And then we can also merge these nodes together. So now I can have a quick look at my system early on and to see if this is already working. So again, we can take the line and we can create a corridor and just do something similar like this to just test out the tool. So I already noticed here a small issue that sometimes in here these are not correctly placed. And what I did to fix it is then over here we have our curvature, and I noticed that over here at my points, if I open the spreadsheet, we have sometimes a value called 0.6 and I'm only filtering here on 0.9. So to make sure this is not happening again, I'm going to here increase the range and also the intensity of both of them. And now we have a better value to work with. So this should be fine now. So indeed, that was just the issue, to just tweak those values. So they're now better. So now we have this as result. And the last thing to do here is to just add a frame and placing it next to this. So that was it for this part. We made the base setup for the builder tool. I hope you enjoyed it and thank you for watching.